Hey everyone, thanks so much for having me. Thank you to AI Camp and AWS for putting this on. It's really cool to be out in San Francisco. I had to rep the Giants hat today because I did a tour yesterday of Oracle Park and that was really dope. Today for the next 20 minutes, we're gonna talk about something that's near and dear to my heart, maybe not the most sexiest part about AI, but I think one of the most important, which is observing agents in production. Now, show of hands, who here knows what Grafana is or has used Grafana? Sweet. So I think it's a pretty split bunch. Well, the skinny on Grafana is we are an open source software company that was built back in 2014. The idea is that you can bring all your data together into one unified view, right? This can be your Nginx servers, your Kubernetes data, your AWS services, Google Cloud services, the list goes on. It can be Python applications. And what you can do is just hook in these directly, right? You don't have to store the data with us. You can just plug right in and start observing. You can visualize it, you can alert on it. We have a plugin architecture that allows you to do that. Now, since then, we have scaled and started building our own databases. We built logs, metrics, trace, and profile databases that you can send all your application, infrastructure, and whatever data you want into them. Now we realized these are all open source as well, right? Free to use, you can run on your own. But we realized over time that these are actually really hard to scale. So we said, why don't we build a cloud service for this? So you don't have to worry about the infrastructure management, the scaling, the security patches. You can just send your data in and not have to worry about it and query alert on it and do everything you want and investigate. You still have Grafana, which is the open source nature under the hood. So you don't have to worry about any of that as well. You can still plug right into 150 plus data sources. But on top of that, we built sort of this layer on top of it that allows you to monitor your Kubernetes infrastructure, your front-end observability data, whether it's coming through from a JavaScript application, React application, anything from your back-end services, Python, Go, Rust, and then what we've kind of are going into, which is agent observability. Now, when we talk about agents, we're really introducing a new kind of production workload, right? Traditional observability, and I still think it's funny because we don't really even have this figured out. I mean, companies have incidents all the time and things break, but it's really infrastructure, application, user data that's flowing in from logs, metrics, and traces. This is heavily microservices, right? Sometimes monoliths, depending on who you ask in the company. But now we have AI, and this has gotten extremely complex. A lot of us weren't prepared for it as engineering teams and companies. We sort of just had to adapt. And we introduced a lot of new signals into our life, right? We have tool calls, we have model calls, we have evaluations, if you've ever set up an eval. You have token cost, you have latency, usage, right? All these metrics and trace data is coming in, and now we have to figure out how that works too, right? And it's still important that we understand the things above. We still need to know infrastructure and application data, because if you don't, you're kind of in a bad place. An API call or a tool call will call an API. That API is probably some sort of microservice that's running on some sort of EC2 instance or some sort of compute. And if that craps out, then you're not in a good place as a company, right? Maybe you have auto scaling and all that stuff, but that's pretty much it. Now, I don't want to spend a whole lot of time talking. I would rather just demo things. I don't know about you guys, but I like that. So, I am going to sort of show you a demo of my agent that I built, which is a financial advisor. Now, if I ask this a question like, how much, by the way, this is my actual banking data, this is fake. So, like how much money did I spend, and sorry, I'm doing this with one hand, so just bear with me. How much money did I spend on food last month? When we make this call to our agent, it's going to do a lot of thinking. And I'm not actually surfacing all the tool calls, but I am kind of giving a preamble, sort of what it's actually thinking in real time. It's going in the background, it's actually calling tools, right? And this is kind of pulling all this information for me. And what's tricky about agents is if you look at this and you read this answer, you might say, wow, really good, right? But the thing is, at scale, you don't actually know. This could be returning very bad output to your users. It could be swearing at your users for all we know, right? Like it could be hallucinating and it could be catastrophic to your company. It could lead you to lawsuits, who knows? And this is really important that we're able to monitor this. So I'm gonna show you this real quick, and this is our Agent Ollie SDK. Now this SDK was built because we wanna be able to observe these agent calls, right? If it's calling a tool, if it's calling a workflow, whatever it's doing, we want to know what's going on with it so that we can see what is actually happening, right? Now, I'm going to open up my Grafana stack and show you a little bit of what this looks like in practice. Now, a quick question while I'm doing this. How many people spend the majority of their day in a harness like Claude Code, Codex? Really? I'm actually surprised. I thought it'd be more people at this point. But anyway, so I'm someone who really doesn't like to leave the terminal or the command line or Claude Code. I like to stay in it. But I'm going to show you a little bit of what agent observability gives us. So what happens when we make a call is we send these traces and metrics into Grafana Cloud, into our databases, and it essentially derives a view from this, right? We see agent observability. We have all these high-level metrics. We have the total request, the error rate, if it's occurring, the eval pass rate. And this is all stuff we can do in agent observability. So if we want to set an eval to say, we want to judge the output, right? We can do that now in Grafana Agent Observability. We track your various agents, your various costs. So let's say I'm running a model hosted in Bedrock, right? And I want to understand how much that's running me. I can see that cost. We use OpenRouter under the hood, just acquired by Stripe, as you may know. But this is allowing us to grab a map of essentially the model cost. We can see that on request, how much that individual call is calling us from a tokens perspective, from a caching perspective, from a latency perspective, and from a monetary cache value, right? And then we see our usage. Now, you'll notice that we also have conversations. And every time you prompt your agent, the Agent Only SDK is sort of wrapping a function call around this. So this is an SDK, meaning you do have to add some code to it. It's not auto instrumentation. It's not magic. It's really just code. But if we look at our conversation, for example, this is sort of what this looks like, right? We can see everything that's happening. Like I have a classifier agent that's actually classifying the request based on what the user asks. You'll see that I have the output, right? It returns some sort of JSON. It says the intent is a data query, so we're going to have to pull some data. It is looking at food and drinks. And then we have a format score. So this is an eval that I'm actually running under the hood. But it's saying that there's valid JSON. It has the correct values. If we scroll down, you can see that we have more of our thread here in the thinking. This is actually our system prompt. And then you can see here, how much money did I spend on food last month? This is what we asked the agent. And then it's going to start to pull this. You'll see that it's grabbing various tool calls, like get category detail. It's going to have coverage. So I actually have a coverage eval that's saying, based on the request to look at food and drink, and I could probably bump this up if you guys can see this a little better. But if you read the eval, it's going to say that it's looking at a subset of calls, right? It made four API calls or 4 tool calls, but there's actually 8 categories that span food. So it's currently not looking at everything. So on the surface, if we read that response, we might say, it's actually doing a pretty good job. It's pulling the right numbers. It's pulling the right cache value of how much I spent, right time range, but it's not getting the whole story, which is really dangerous, right? And what's cool is with these evals that we actually create, we can set alerts based on them. So you can see that there's evaluations, and I have all these kind of laid out. Now inside of an eval like this, we'll say the FIFO category coverage, we can see that this just ran. And we can see the results and the performance, the conversation that it failed on, and then we can see the latency for all these, how much it cost us. We actually host the evaluators in AWS Bedrock. So if you have an LLM judge, let's say you want to know, okay, I made a request or a prompt, and I want to know if the LLM judges this as good or bad. It'll actually run on AWS Bedrock, return the value, and the LLM will actually score whether this is good or bad. Now, you'll notice that if I look at my code editor, I'm going to drag over Claude Code, and then I'm going to go in Slack. You'll see that I actually have this hooked up directly to Slack. So when an alert fires, essentially you'll see the eval category has failed over the 1 hour window. I want a pass rate of 90%, but it's below that, so that's problematic. And you can actually start to build reports with this too. So let's say every 24 hours, every week, you wanted to know how many of my evals are failing, what's problematic in my agent, what can I go and review as an engineering team to be able to understand what's going on and to improve it. And I'm going to show you that loop. So one way we can do this is when the alert fires, we can actually investigate this alert directly into Slack. So this will actually call the Grafana assistant, which is another feature in Grafana. And this will actually run an agentic workflow to be able to look through all your telemetry and discover it. This is not just in Slack, this could be in Microsoft Teams. You can also funnel this data through something like ServiceNow or PagerDuty, whatever you want. But let's go to the Cloud Code use case here. So something that this is going to do, and what's really cool about Grafana and its open source nature, we built this command line tool called GCX. And GCX is going to do some really neat stuff under the hood. So it called the GCX skill for Agent Ollie that we installed in Cloud Code. You could do the same thing for Cursor. You could do the same thing for Codex, insert C agent harness here. It works for all of them. It essentially will write into the agent's path, and then it'll actually go and look at these conversations. GCX has a way of understanding everything in Grafana Cloud, so it can go look at the conversation ID that is actually passed through Agent Observability. It knows how to write the queries for you. You don't have to worry about any of that. And it'll actually just start to infer and build everything for us. So we can bring this directly into Cloud Code. You don't even have to go into Grafana anymore or your observability provider as a whole. It's going to start to look at all this data, and it's going to actually cross-reference it with my code base eventually and be able to improve a fix for me, right? So the idea is that we create this loop, and I feel like this is sort of happening in the software development lifecycle right now, where we sort of had this process where it was kind of looking at like we'd have a product requirement, we'd go and build it, we'd monitor it, then we'd go and kind of restart the cycle. We'd have design sprints and all that. But now it's sort of a lot faster, right? Like now, an engineer can do a lot more, right? You can start to understand your infrastructure. You can start to understand your applications that you don't own. And you can start to close the loop, especially with agent observability, right? So now it's going to give sort of this whole breakdown of what the real issues that the evals caught. Right, so the prompt returns only a JSON object, there's no explanation, there's downstream parsers that will likely strip it. It's looking at everything that's going on. There's preamble hallucination, response skips for the 7 required sections, so I can actually have and go fix number 4, which is, I think, the biggest thing. If it's not calling all 7 or 8 of the options that I need for food, when it pulls that up, it's going to look at that. And I think that's super important because I don't want to be giving my users bad experiences. So you can see that there's instrumentation gaps here that we can improve with agent observability. If you're trying to instrument your agent for the first time with GCX, if you just ask like, hey, go instrument my application, it'll actually call the GCX skill to do that in production. This means it could have guards, like let's say you don't want it to surface any sensitive information. Let's say it's like social security numbers that you want to be able to sort of like block from being written into Grafana Cloud, or maybe you don't even want an LM request to be made if there's some sensitive data. The agent observability production skill will actually look at that in your code base and say, here's where I think pre-flight that we should block that from happening. So there's a lot of cool stuff that the agent observability SDK can do for you. Right now, this is actually instrumented on LangChain. This is a LangChain agent that was built using the Anthropic API. You can do this through Bedrock and Agent Core. You can do this through Google ADK. We have a bunch of support for Codex, and you can even monitor Cloud Code, which is really, really cool. So if we go into agent observability, you'll see that I actually have Cloud Code here. So like this request I just made, please analyze conversation, blah, blah, blah. It actually wraps Cloud Code too. So I use this right now to improve my prompting, because sometimes, like I said, it can kind of be very broad and bad. So this will surface all the grep calls that you make, all the the sed, awk calls, whatever it's doing in the command line. You can actually start to monitor this and flow it into Grafana Cloud. And you can see if we go back here, like I said, we can also have the assistant investigate this. So what's funny is this actually came up with a relatively similar inferred root cause to what Quad Code came up with. It seems like Quad Code gave me a little bit more and from a different view. But the idea is that you flow all this telemetry from your various services. Now, if you're a developer that's running a huge microservice architecture with hundreds of services at petabyte scale, even for at the enterprise level or the mid-market, and maybe you have 50 engineers, you can start to close this gap. And you can start to understand aspects that you didn't before, right? And I think that's what this is all about, and what we're trying to get to as a company, as a product, is to be able to close that gap so you can gain more insight into this. So yeah, I think that's pretty much all I had from like a high level perspective. I will go back into this and I'll pop up the QR codes. This is a QR code to GCX, which is our open source agent, or open source command line interface. And then Grafana Cloud has a generous free tier. So if you want to go and get started with Grafana Cloud, we give you a ton of log data that you can just get up and running with, send your data in, and start to sort of monitor all your applications. So thank you, guys.
Mm-hmm.